Super. Oh, rule बघ.
Good morning to all of you. So on behalf of National Jal Jeevan Mission, I welcome you all to this webinar. Today's topic is engineering principles and design for assured potable water supply to every rural household. So before we go to the webinar and the content, so I would request to all of you to kindly mute your audio, and whenever there is an interaction, then you can switch on the audio. So as you know, the Jal Jeevan Mission implementation is in full swing in all parts of the country, and all the state governments and UT administrations are working tirelessly to achieve the goal of Har Ghar Jal, that is every rural household will get assured water supply in adequate quantity and of prescribed quality on regular and long-term basis. So in this context, the different teams of National Jal Jeevan Mission are visiting different states and UTs. So multidisciplinary teams comprising of various technical members are visiting states to find out what are the issues, challenges, provide technical assistance to the states, as well as interact with them, with the field officials. So during this field visit, so we have come across different gaps, various gaps, what has been laid down, the basic principles of Jal Jeevan Mission in the operational guidelines, and with respect to planning and implementation, how it is implemented. So some issues are there. So in order to overcome these issues, these challenges, this webinar has been designed so that the engineering colleagues from states and UTs will be benefited, so that will be able to achieve the goal of Har Ghar Jal. So with the changing scenario of infrastructure creation to service delivery as mandated under the Jal Jeevan Mission, so we have to reorient our strategy so that is in alignment with the objectives of the Jal Jeevan Mission. So in this context, it is our endeavor how to ensure cost-effective solutions which is easy to operate, maintain on long-term basis. At the end of the day, it is our endeavor we should ensure that the source and system sustainability happens over a period of time. So that is the aim of the Jal Jeevan Mission. And secondarily, it is very important that the public expenditure is done in a prudent manner with effective convergence with the other government schemes, so that a reliable and trustworthy arrangement for water supply systems can happen in the rural areas. So in this context, we have plethora of issues starting from source sustainability to water supply, grey water management and operational maintenance will be dealt with in today's webinar. So the famous co-founder of Apple, Steve Jobs, once said, the most powerful person in the world is a storyteller. The storyteller sets the agenda, vision and the values for the generation to come. And for this mission, Jal Jeevan Mission, our mission director and additional secretary, he sets the agenda and the vision for the mission for the whole country. So his vision and thoughts are reflected in the every page of the operational guideline of the mission. So in today's webinar, so he the first speaker, he'll be setting the context, setting the agenda. Mr. Lal, born in Prayagraj, has his masters in medical biochemistry, and he has carried out some research work in All India Institute of Medical Science, Delhi. A civil servant of 1988 batch, Sri Bharat Lal is currently the additional secretary and mission director of the National Jal Jeevan Mission. So for a long period, he has worked extensively in the drinking water sector in Government of India as well as the state of Gujarat, and he was one of the pioneering force in creation of water and sanitation management organization in Gujarat that led to the decentralized community-led water supply system. Post-earthquake in Gujarat, Sir had set up this organization which facilitated potable water supply to different parts of the state. So this work has been widely recognized even by conferring the organization Prime Minister Civil Service Award, Commonwealth Association of Public Administration and Management Award, and United Nations Public Service Award. Mr. Lal has vast experience in policy making at the highest level, both national and international issues. Prior to these postings, he was Additional Secretary to Honorable President of India, and he has the privilege of working with Honorable Prime Minister of India since 2001 when he became the Chief Minister of the Gujarat. Presently, he is in the strategic team managing the COVID pandemic. So without wasting much time, now I'd request Sir to share his views and guidance. Over to you, sir.
Good morning, friends. Namaskar, and I welcome my co-panelist, Mr. Hingorani, who has worked in your public health department of Chhattisgarh and earlier combined Madhya Pradesh. Mr. Rana Singh, R. Singh, who is NIC web room. You are requested to mute your NIC web. Kindly mute. Okay, no problem. So, and other my speaker, Mr. Muralidharan, who is here holding charge of Additional Advisor, Public Health Engineering Unit, and my other colleagues, Director, Mr. Ajay Kumar, Mr. Manoj Sahu, and Mr. Pradeep Singh, as well as Mr. Rajshekhar. First and foremost, I welcome you all, and especially on Saturday, you all have joined. And thank you very much for joining. Let's understand that today's topic is extremely relevant, not only to public health engineers, who are involved in planning, designing, implementation, operation and maintenance, but other stakeholders who are sector partners, NGOs, or even Gram Panchayat people, or anybody. So please understand, today we have tried that people, as you know that different teams have gone to different states. They have understood the challenges faced by our colleagues in the field. They have also tried to understand, comprehend that what kind of new knowledge, new information should be shared, so everybody should be on same page. So this effort, today's effort, is basically to bridge this gap. You people in the field are master. You know everything. What is the problem? What are the issues? What are the challenges? Question is, how efficiently and effectively with minimal investment this problem can be solved. And more importantly, please forget, this is not a project, I repeatedly say, it is not about infrastructure creation. It is about service delivery. So I think in the field, everybody has to start thinking that in this village, in this area, in this group of villages, I have to ensure that every household gets sufficient water of prescribed quality, regularly, very assured basis, dependable, no alternative arrangement to be made. So we all have to start thinking about daily running a system. That system, as you know, for one deputy engineer or junior engineer, not possible. For 50 villages or 100 villages or 200 villages, one engineer goes to house and run the system. No, not possible. To check to check whether people are getting water or not, quantity is sufficient or not, quality is all right or not. For one deputy engineer, for one executive engineer for his 600-700 villages, no, not possible. It means we have to have two strategy. At village level, at some intermediate level, somebody has to manage who stage lives there itself. And that is the concept that Gram Panchayat or Village Water and Sanitation Committee or somebody will be managing it. Right? And second thing is that when the focus is on running the system, it means we have to sort out, we have to develop system in such a manner, and 24/7 we will be focusing on how system operates, how system is run, how system is managed, how service delivery is done. I have only just this point. And end of the day, it's a public money. It's a taxpayer's money. So each and every penny has to be used judiciously, in a very prudent manner. We can't afford to waste money. I think Indians by nature, in the worldwide, we are known for saving money. Worldwide we are known. We are also known that we always try to get value of the money, whatever money. If I am going to buy a shirt, I will say that I should spend minimum, but I get quality shirt. So we are known. This national characteristic, this societal characteristic has to be reflected in our work. If in my personal behavior, for my home, for my this thing, if I have to arrange a wedding of my son or daughter, I will go into such a minor detail that I would like that whatever money I am spending, I am going to get value for this money. My humble request is to my engineers colleague is that this mindset, you should not be an artificial person. Your character, your ethos, your value system, which is your natural, that must get reflected when we are working in the field. That is our natural character. Why this money I am spending? Can I do it in much better way? Can I do it in much better? Secondarily, let's treat others the way we would like to be treated. As I said earlier also, when you construct your own flat or house, you give a detailed briefing to your architect to design. He is a professionally qualified person. But you always give him detailed briefing. What are your requirements? What you are looking at it? What you are doing? Similarly, if users are the village people, I think if we are not listening to them, we don't understand their requirement, and we have this arrogance that we know all. We know all. We will construct, we will design everything and give it to them that they should run. I think let's not have this contempt for our own brethren. Let's not have this contempt to our own. You and me have come from the same soul. Let's not have this contempt for our parents, our brothers, our sisters. No, that's not very fair thing. I think listening to people, listening to them, what they want, as when you construct a house. The third point I am saying that as a professional, I think this, except our education system the way it is, it's reality. When we are doing our engineering, let's say mostly civil engineers are here, maybe some mechanical engineer or computer and electrical or electronics engineer. As you all know that what we are taught about public health engineering in our civil engineering graduation course, I leave it this judgment to you. Whether we are taught water supply infrastructure, overhead tank, sump, supply, all those pumping, or we are also taught about public health engineering, or we are also taught how to run a utility. I leave this judgment to you, what all we are taught. And the very next stage is what we are taught when we join government service. What kind of training we are imparted? What kind of training? So the second thing I would like to leave it to you, that what are the gaps? The gaps. Here we are in the business of that Jal Jeevan Mission. When you are working, you will be working, but simultaneously want that you should also learn and improve. We want to help you in realizing your full potential. We are in business of empowering you, improving your capability, your educational your knowledge, your ability. And in fact, for that purpose, we are going on in a big way, very big way, in capacity building, training, reorientation, change management. We are working. We want that you should be a truly a utility manager, truly. And for that utility manager, I think we have to first understand this habit, this nature we have to develop, that sitting with people, sitting with the stakeholders, understanding their problem, and then giving them technical solution. Just presuming that I know their problem, I know their challenges, and I can give directly technical solution, that may not be a great idea. I think this we have to internalize before knowing, listening people's expectation, aspiration. Let's understand we should not start giving our solution, our designs, our estimates, are those things. Thirdly, I repeat, as we all know, nation is undergoing under tremendous stress. Stress is at family level, in personal level, family level, societal level, financial level. We are undergoing huge stress. For a government where 30% revenue lost, paying salary, paying pensions, paying for our security, law and order, I think those are priority. Above all, I think saving people's lives, their hospitalization, creating facilities. I think at this time, this juncture, each and every Indians, you and me, it's our responsibility to directly or indirectly contribute in mitigating this problem. How we can contribute? I think as a public health engineer, if we ensure that we will get value for money, we will ensure service delivery, I think that is the biggest contribution. If we don't waste money, if you don't waste money, I think that is your contribution. If you save few lakh rupees or crore rupees, that is your contribution. So in my opinion, by your innovation, by your technical solution, by your problem solving approach, you can make huge contribution and make your own life very meaningful. That in this crisis, I contributed. You can tell this story to your children. You can tell this story to your grandchildren. You can build their character, their ethos, their value system. That when nation was in crisis, what happens in military? In military, people with pride, they tell their children that honor, that bloody in this war, in this problem, my father gave his life. My husband gave his life. If by any chance I was alive, I contributed in this way. I think you will have a lot many stories to tell, that when this change was taking place in this country and country was in real trouble, I think as an individual you contributed. Kindly have this spirit, kindly build your team with this spirit. You are a leader of your men and women. You are a team leader in your own area. I think this character, this nation building, this we have to adopt. Nation building is not the responsibility of only Honorable Prime Minister or Honorable Chief Minister or top civil servant. Nation building is each and everyone's responsibility, whether small or big. And today, since Jal Jeevan Mission is the topmost program, the most critical and most important program of the government, I think you have got the golden opportunity for nation building. Friends, I will not speak much because I have set the agenda already in last 2-3 through this thing. Today, it is more about, if we imbibe these values, these ethos, how to build our capacity. If हमारी सोच ऐसी है कि इस नेशन बिल्डिंग में पार्टिसिपेट करना है, पैसा वेस्ट नहीं करना है, उस पैसे की पूरी वैल्यू मिलना चाहिए, तो मैं कैसे करूं? I think we have assembled 3 eminent people here who have got better experience of life, whether it's a field or in the policy making or on the ground. I think this is a time for their experience sharing. I mean, they are here to help you to realize your potential. They are not here to hold your hand and ask you to do it. No. They are here to share that perspective. जिससे आप अपनी जिंदगी को बेहतर बना पाए। आप पढ़े लिखे लोग हैं, समझदार लोग हैं, आपको इससे बढ़िया मौका नहीं मिल सकता है। आपकी जिंदगी को मोर ऑनरेबल बनाने के लिए दे आर हियर। प्लीज अंडरस्टैंड, लाइक यू, सैटरडे को आप इस लेक्चर में उसमें शामिल हो रहे हैं। दैट शोज योर कमिटमेंट, that your commitment to make your life better. By making your life better by what? Doing things better. Doing things better. Ensuring and achieving the goal. Similarly, on this holiday, on this time, they are also trying to make their life better, that they have this knowledge and they would like to pass on to you. Let's understand, let's appreciate, let's try to pick up that knowledge, that information, that tactical thinking, that strategic thinking. Second, I think I'm very happy to note that because since beginning I had this understanding, not I, rather we, that this Jal Jeevan talk is essentially a Jal Jeevan Samvad, Jal Jeevan dialogue. It will not be a one-way lecture, no. And we would like, and we encourage, and we would like to see it that each and every episode, whenever you are holding, more and more your good experience should be shared here. It must multiply, it must amplify. Your good experience in one district, one subdivision, one village must be shared so that it gets amplified and rest of the country people can understand and can little bit follow it. Friends, I hope and I believe that once you have joined this group, you have absolute conviction about these ideals. These are the ideals, we are going to live by these ideals. There cannot be any other way. These are the only ideals, we are going to live with it. And for it, I think you must have heard a very famous quote, if you have not read. There is an autobiography of Nelson Mandela. There is an autobiography of Nelson Mandela. It's a 2-volume book. I strongly recommend that you must read that book. I think it will be an eye-opener. Imagine that 27 years the man is behind bar on Robben Islands, day in and day out, enduring humiliation. He knows that yes, he was saved from death, but well, he will not ever see light. But he never lost hope. He had this conviction and belief that he will be able to make others' life better. He was not bothered about his life. He wanted to make others' life better. And see, that determination, that belief, that conviction led his release. I think I would like to share his one small you can say anecdote about him. There is a very famous, in that book, in first volume, there is a very famous story. There is a case actually, this is very famously known, if you can Google it, you will find it. It is known Veronia trial. Veronia trial, okay. He was accused for sabotage. For that sabotage, he was basically charged for treason. And treason, it was proved. It was proved that he conspired to overthrow the government in Veronia trial. And these were, I think, 8 people. 8 people. There were 8 people who were charged for. एक हिंगोरानी साहब आप अपना माइक ऑफ कर दीजिए, म्यूट कर दीजिए, माइक को म्यूट करिए प्लीज. So Veronia trial, when this came, when he has to give his statement, it was a 5-6 page statement, and what he said in the last, that carries value. He said, I don't remember the verbatim, but essentially he said that I had dream to live in a free South Africa, free, where everybody is equal, where whether whites or black, nobody is dominating on anyone. So I have a dream, and I wanted to live in this kind of South Africa. But if I cannot live in that kind of South Africa, then at least, and I am prepared to die for it, for that ideal. I want this dream to be fulfilled, but if by any reason I cannot fulfill this dream, I am ready to die for this dream. Friends, you have certain ideals. In public health engineering is all about giving clean water, saving people's life, improving their life. These are our dreams. And I think we have to. There is no reason for us to die for that dream. But we must live for that dream. And we must do everything possible to realize that dream. That is not negotiable. We have to. We cannot see our dream to fail. The day you joined, this was the dream. And I think we must realize that dream in our lifetime, in the next 3-4 years. I think with these words, I'll stop here. Because today it is more about finding solutions to realize those dreams, how to work and how to find solution. So I request my co-panelists to basically speak, and thereafter we would like to hear those stories, those great work being done in different parts of country. And next time, whenever we are going to hold, we will hear such more stories, more such solutions, more such great work you are doing. Kindly make this channel, this forum, Jal Jeevan Samvad, both in print, in electronic copy, as well as this day. Make your own. You should be sharing. You should be taking initiative that, you should be posing question. You should be suggesting that we should be talking about this issue. Friend, before I close, I'll just make a couple of announcements. As you know, 25th December is Good Governance Day. 25th December is Good Governance Day. Kindly make your resolve that leading to this 25th December, what all you would like to do to bring that good governance. And in your case, good governance is nothing except clean water, assured clean water supply, assured quality, very regular, dependable. So please make that resolve, realize that in next 7 days what all you are going to do to make 25th December a special day in your life. Is a good governance day. And few things we have planned which will be shared at the fag end, that what we are going to do on 25th December on Good Governance Day. Our purpose is that, I'm here to just get you that respect, that recognition. A silent worker like you should get that respect, that recognition that you are doing great work. To get that respect and see, many times we do great work, good work, but we never get recognized. But let's also understand that if that work should be recognized, then it must be good work. That is a prerequisite. Onus on me is to get you recognized, but onus on you is to do that good work, that truly good work. And my responsibility is to get you recognized for your good work. So coming this 25th December, as we all know, we have certain clear-cut goals under Jal Jeevan Mission, clear-cut timelines, clear-cut transparency, website, database, as we put, dashboard we put. There are certain, this thing, 100 days campaign, laboratory testing, and this thing. So there are certain things which at the fag end we will be talking about it. But here I'll stop and I'll hand over to my colleague, Mr. Manoj Sahu, to take it forward. Thank you very much. Thanks a lot.
Thank you.
All are requested to kindly mute. All are requested to kindly mute their mic. Kindly. Because please understand, you might be whispering or speaking small, this thing, it disturbs everybody. I think these are the etiquettes. These are the etiquettes in modern times when we are using online and these systems. Let's keep the two things in mind. Please don't mind what I'm going to say. A, always your camera should be, try to have camera at your face level, same level. Just imagine if camera is here, it will looking into my mouth and internal nose, and nobody want to see our nose inside. So camera should always be in front, at your eye level. Keep this basic principle. And second basic principle is always keep your mic mute. When you are going to speak, please raise your hand and you. And third, suppose your bandwidth is poor. Bandwidth is poor. Video should also be muted. Video should also be muted if your bandwidth is weak. Over to you.
Thank you very much, sir, for sharing your thoughts and what is expected from the engineers especially. So, which will certainly inspire the scores of officials and other stakeholders to imbibe the ethos and the principles of Jal Jeevan Mission. So, in this series, our next speaker is Mr. Muralidharan. He is Deputy Advisor in the Ministry of Jal Shakti, Department of Drinking Water and Sanitation. So, Mr. Muralidharan is a B in Civil Engineering and having a degree of PG Diploma in Information and Technology. So, he has vast experience of 27 years in water resource and water supply sector at field and policy level. And he has worked in both the Central Water Commission as well as the Tamil Nadu Water Resource Organization for 9 years in dam safety and water resource development. And also he was associated with the 10th, 11th and 12th 5-year plan formulation in respect of water resources and water supply sector. So presently he is with the ministry and he is with the Jal Jeevan Mission since the announcement last year from 15th August 2019. Now I request Mr. Muralidharan to talk about the engineering principles. Mr. Muralidharan.
Thank you very much to the mission director and to my colleague, all the senior officers from the state governments. Very good morning to all of you. So we would like to share a small presentation about the basic engineering principles that is adopted in the Jal Jeevan Mission. It has come from the guidelines. It's not something new that you are not aware of, but just to put in perspective as well as to share some of the field observations that have been made by the different teams that have gone to the states. So that will help us to understand the difficulties that we face in the field or how the works are actually executed in the field and how to correct if there is anything that needs to be corrected. So some of the key engineering principles that we mention here. The first and topmost, as the mission director was saying, was demystify the water supply engineering for community participation. The aura of engineering is there always and it continues to be there, but it has to be a frugal engineering so that the community can participate even after the post-commissioning, and that's one of the major aspects of this from the beginning from planning to taking over the systems and to do the operation and maintenance. So it is important that the water supply engineering is demystified to the community so that they are not frightened by the engineering aspects of that. So one of the major aspects of this is to do that. The second is end-to-end solution from source to creation of infrastructure to service delivery, which was again emphasized upon. The program is not about infrastructure creation but about service delivery and even beyond grey water management so that the villages do not become, do not have the cesspools of wastewater that gets generated because of additional water supply. And the third one is priority for decentralized, simple, low-cost systems so that people can actually maintain them easily. Constructing some big mega structures and then providing water is very good. That is required for certain areas, no doubt in that. But not all places require that. We will see that how that can be done. And again, optimum utilization of the existing resources. We have a large number of resources, engineering structures already set up under various 5-year plans, even by the state's funds, NABARD funds. All those assets have to be actually dole-tiled under the Jal Jeevan Mission so that you don't create infrastructure, but you utilize the existing infrastructure for provide excellent service delivery. And the last and again another point is sources and structures. They have to last for the full design period. There is a design period concept. We all are aware of that. 15 years, 30 years. So all our structures and sources have to last for this complete period. And two of my colleagues will be speaking about that later on in the program. Next slide, please. Again, the big multi-village schemes, or what we call as regional projects or grid-based water supply systems, you have to have value engineering starting from planning to the delivery of the construction and delivery. It has to have a low capital and life cycle costs. In-village infrastructure, it's clearly defined in our guidelines what constitutes an in-village infrastructure and how they have to be done so that it is very easy to do the O&M by the community post-commissioning of that. The country of the size of India has got different types of terrains, so we need to have engineering solutions for different types of terrains. We have coastal, hilly, cold areas, hot areas, deserts, all those areas. Then there are different factors that govern the selection of your materials that cost around 60 to 70% of your project cost. How do you actually select your pipe materials? That will again be dealt in this program. And equity in service delivery. How would you ensure that a certain part of the village gets more water and certain part is deprived of, especially the poor and the needy, the SC and ST? How would you ensure service delivery to everyone? And last but not the least, how would you actually use the latest technologies, internet-based solutions, internet technologies for monitoring? Next slide, please. So how would you actually demystify this engineering? If you the flow started from the Honorable PM itself, when he said that the community must have the sense of ownership of the assets that is being created under the mission. This is the bottom line that we all have to understand, that whatever assets we create, that would be managed by the committee and community. I understand that big structures would still be with some of the major departments, but especially in village infra, that would be only managed by the community. So how would you do that? It's already explained in our guidelines. We have village action plans detailed, what are all the points that needs to be covered under that. The Gram Panchayat or the village water and sanitation committee, they have to be involved from the beginning, from the planning stage to the implementation stage and through management and operation and maintenance. Then the community is again involved by approving this village action plans. So the village action plans have to be approved by the Gram Panchayats and the community. And please understand that there will not be any additional component to be included in the DPR for funding, which is not part of the village action plan. So the VAP is a comprehensive document that would include all your estimate assets. The assets that you would include as part of the estimate, nothing will be going beyond that. So it will be a very comprehensive document by itself. And implementation part, the community will be involved by undertaking social audits of the structures, both quantity as well as quality. In terms of management, it would be the responsibility of the VWSC or the Gram Panchayat to take over the day-to-day operations of that, post-commissioning and hand it over to them. And operation and maintenance, the VWSC or the Gram Panchayat have to work as an utility with community contribution as well as funds received from the finance commissions of both center and state. Next one. We now come to the principles of source selection and sustainability. While I'm not going to go into the complete engineering aspects of that, some overarching views would be shared here. If there was a document by the Central Groundwater Board in 2017 that talked about the number of safe blocks in the country which have adequate quantity of water, and in 2018 the same organization came out with the quality aspects of groundwater in different blocks. Now we in the ministry merged both, and we found that out of the 6,834 blocks, we have around 3,775 blocks which are safe, in the sense they do not have any quality issues nor they have any quantity problems. You will be surprised to know we have a list of states. For example, Jammu and Kashmir, Jharkhand, Chhattisgarh, all northeastern states, they have more than 70% of groundwater available in all the districts, in all blocks. If you take Bihar, Kerala, Uttar Pradesh and Uttarakhand, more than 50% of the blocks have both quantity and quality. If you take West Bengal, Maharashtra, Madhya Pradesh and Gujarat, they have more than 40% of the blocks that have both quantity and quality. So in these blocks, without going in for any big multi-village schemes, it is quite easy to supply water through a simple village scheme, so saving much of the cost. Again, If you see you can, of course, use of hydrogeomorphological maps, services of the groundwater departments would be used for selection of your sites. While designing, you will have to ensure that the yield is certified by the source finding committee. It is part of the guidelines, it's mentioned. And when we visited some of the states, we found that most of the bore wells used for drinking water supply are situated very near to the agricultural fields. See, agricultural fields have a number of bore wells, right? There is a tendency that if a farmer owns around 5 acres of land, for each acre he has a bore well. So there are multiple bore wells which are yielding water for agriculture, and the aquifer that provides water is the same, whether it is for agriculture or for drinking water. So the same aquifer catering drinking water as well as agriculture, if they are going to draw water simultaneously, your systems are going to run out of water. So please kindly locate your structures in such a way that the radius of influence of agricultural bore wells have least influence on drinking water bore wells. Again, we have found in the field a number of DPRs have been seen from in the states, and we are very sorry to inform that the detailed borewell recharge structure is supposed to be a part of it, a dedicated recharge structure for borewells are not forming part. So this is being funded under the mission. Earlier it was not funded. It was removed from the NRDWP sustainability structures. We have brought it back. It's important that we include it so that your sources are sustainable. And DPRs to include recharge structures exclusively for water supply, and they will be funded through the MGNREGA and other IWMP and RRR of water bodies programs of Ministry of Water Resources. Next slide, please. And there are many states that adopt engineering canals as sources. Haryana, Andhra Pradesh, many of them have. It will be a good idea to have some storage structures during the summer seasons. Most of these canals do not run 12 months in a year. They run for a certain period of time. 2-3 months they are closed for maintenance. In such cases, state of Andhra Pradesh has got a concept of summer storages. They create summer storage structures in villages and they store water, and then they use this water for water supply during the periods when the canal is not running. And when you are tapping your sources from dams or barrages or from rivers, kindly ensure that you get the dependability certificate from your water resources organization, which should be 95% as per the CPHEU manual, so that you do not run out of your surface water sources while supplying for multi-village schemes. Again, coming to the existing repair of existing water bodies, our field visits have shown us there are large number of water bodies owned by different departments. Some of them are owned by water resources, some of them are owned by the Panchayat Raj department, some of them are even temple tanks or community tanks. Please include them as part of your VAP so that they can be repaired under the MGNREGA and the water security for drinking water can be improved upon. Again, in one incident we came across where there is a contamination of existing sources. The tendency is to shift the source from contaminated source to the non-contaminated source. The non-contaminated source is somewhere around 30 kilometers away. They are trying to bring the water from there. I don't want to take the state's name here. That's going to add to your DPR cost. Please do not do that. Try to address the issue of contamination. Take it up with your SP, State Pollution Control Board, and get it addressed. Otherwise, you are going to run into a huge expenditure for creating systems for multi-village schemes especially. In rocky terrains, for groundwater recharge, you've got conventional recharge techniques. For your information, the Groundwater Survey and Development Agency of Maharashtra has got excellent knowledge on various techniques for recharge, especially in rocky areas. We will be very happy to share the details with you, and you can also directly approach them. The ministry can handhold it. They've got a lot of recharge techniques. They are all very big in their own way. If I start explaining them, that will take a lot of time. These are borehole blasting, fracture, seal cementation, and stream blasting. These recharge structures would help you to maintain your borewells which are located in the rocky areas. Coming to the drought-prone and desert areas, you can have big storage tanks. There are large storage tanks that have come up now. We have got zinc aluminate tanks, steel bolted zinc aluminate tanks are now available. In Palghar district of Maharashtra, large such dams have been, such structures have been put up so that water availability is there even during summer season collected from the rain. In combined water supply schemes, you can increase your water security. We saw an innovative example in Tamil Nadu's Erode district, where there is a village, it has got a rain gauge, There is not a drop of rain in this monsoon. The country received excess monsoon this period. Not a drop in the last 4 months, but with 25 mm of rainfall somewhere in the month of June, they collected around 25,000 liters of water, and they are actually using it conjunctively with the water supplied by the TWAD board through the combined water supply schemes. We have seen such innovations on ground. It's really appreciable. So such innovations are to be replicated in this mission. And again, the water storage tanks which act as a water security, they can be fenced and restored under the MGNREGA. I think somebody has to mute the mic. I am getting an echo here. So encourage social policing. Andhra Pradesh women self-help groups and the water sanitation, village water and sanitation committees, they do social policing and ensure that the summer storage tanks and their water tanks are not contaminated. For spring sources, identify spring sheds for the development maintenance. We have got isotope-based hydrology, which will help you to delineate that. We can share that details with you later, but it is quite a big subject, so I'm not dealing it here. Next slide, please. So in village infrastructure, there is a lot of confusion in what actually it is. Kindly see page 38 of the guidelines. It is defining that in village infrastructure for both MVS and SVS. In places we saw the in village infrastructure includes the elevated service reservoir in the villages. In many places we have seen the water that is supplied through combined water supply treatment by the departments are still maintaining those tanks. It is supposed to come in the in-village infrastructure of the village. So there is a confusion about what is actually an in-village infrastructure that needs to be now solved. It's clearly given in the guidelines. Existing assets have to be mapped and plan for repairing and strengthening them, for dovetailing them instead of constructing the new ones. The design period of the infrastructure, I'm not talking about the source here, the design period of the infrastructure should be based on the effective life expected. Considering the current advancements, there is a tendency to lay new pipelines for those water supply schemes, even which are functional, which are hardly 8 to 10 year old. Schemes are being taken up, which should be avoided. Routine 15-year recommendation should be avoided. Laying of pipes should be at proper depth. In many places, concrete roads are being laid by the rural development departments. There is a tendency to lay the pipes on top of the concrete road. They are bound to get damaged. You have to follow the CPHEO norms for laying. Even in one place in a northeastern state, we found that plastic pipes are being laid on top of the concrete roads. They are bound to get disturbed even by a small cycle or even by a motorbike. So kindly see that the pipes are laid at a proper depth. Filtration plants, we found that some places people, just blindly adopt rapid sand filters. It's actually not required. Many places even repairing or existing slow slant filters, changing the filter material will yield you more water than constructing a new one. So always kindly have a frugal engineering approach so that a lot of thinking goes before actually adopting them on the estimates. And we recommend the radial distribution system for, village with 4 or 5 habitations so that everyone gets equity water supply. Next. Some of the states like Telangana and Tamil Nadu are now using flow control valves that restrict the flow up to about 5 liters per second, 5 liters per minute. We have issued an advisory in the month of July requesting all states to adopt this. Kindly adopt the flow control valves between your ferrule and the supply. And we also suggest that location of bathing and washing complex to be nearer the community toilet so that ease of use will be there instead of locating them at different places. Cattle traps are to be adopted in desert areas. Don't adopt cattle traps in areas where you've got excellent, water security structures like water tanks or something. It needs to be adopted only in places like deserts. There is no need to have them at many places where the water is already available in many other structures. If a system is requiring retrofitting and augmentation through additional source, don't do augmentation unless and until the population projection demands. We found that in one state, the population projection is adopted at a constant rate, which is beyond the norms, and it is not recommended. That will increase your cost ultimately. Please adapt aerators wherever is possible. In one Anganwadi in Tamil Nadu, we found that one Anganwadi worker spent her money, spent 150 rupees or 200 rupees and kept an aerator, and that really helped to save a lot of water. So that sort of good principles are happening already. Good things are happening on ground. So we need to emulate that. And selection of pipe materials, my colleagues will speak. Next slide. And how would you have that low cost O&M by communities? Only suggest decentralized schemes. We have a large blocks, 48% of blocks have already quality and quantity. Only for drought prone areas, you have to suggest multi-village. Don't go for this where it is not required. As far as possible, avoid widespread location of village assets. We found that there is a there is a long distance between your reservoir, elevated service reservoir and the village. It may be there located for the purpose of gravity, but kindly ensure that the selection of places, sites are done in such a way that the cost is optimized. Provide energy efficient star rated pumps, conjunctive use of solar and electrical power. In one multi-village scheme in Odisha, we found that the cost of electricity for pumping came down by almost 4,000 rupees when they started adopting the solar and electrical power. There is no need to provide individual household connections in areas which are less than 20 households, where you can provide a cluster-based approach can be used, where you can have a solar-based schemes. We have an exclusive provision in the guideline for a 7 lakh solar-based schemes that can be used in those areas where we have less number of households. Next one. We have also issued an advisory very recently, maybe a week back, about the gravity-based source usage. Meghalaya is adopting a lot of gravity-based source that helps them to reduce the cost in pumping. It's a very good thing. And wherever, when your groundwater fails, constructing storage tanks helps you. I have already quoted the example of Palgad and Erode districts. I'm not repeating here. Next one. For terrain-specific solution, use desalination as a last resort. We found that some of the coastal states have adopted desalination plants. 89 rupees, 90 rupees per kiloliter of water. It's very, very costly. Please use that as a last resort. In cold desert, you can have different, I'm not repeating them, some of them will be covered by my colleagues. There is one excellent book available in the website called Out in Cold. You can Google that and find out. If you Google it, you will go to Amazon, that there is a book also called Out in Cold. It's a story book. Please don't get, diverted with that. There is a book called Out in Cold prepared by a UK university by one Mr. Smith. It's an excellent book on how you should have to have the infrastructure planning for very cold areas, especially in Himachal, Ladakh, J&K and all. Then for drought prone areas, we have, as the guideline also allows for regional grids. Next one. And then this end point is this grey water management. We have found in many places in villages, in the village action plans, have not included this part. Kindly please include, this is one of the most important aspects. There are some good examples. Again, I'm taking an example of a southern states that has done excellent work on grey water management. Every household tap connected, the new connections under Jal Jeevan Mission, they have separately provided a soak pit under the MG and RAGS. It's an excellent example of convergence. Not only that, they have even gone ahead and done a community-based, this soak pit, where that water is treated through an horizontal filter and it is being used for plantation. So it's an excellent use of your water that reduces the water use for plantation, fresh. It so saves your fresh water. So kindly ensure if one state can do, definitely all others can also do that. And the technologies for this grey water management is clearly outlined in our SBM guidelines. It's there in our website. We don't want to repeat that. It can be adopted straight away. And then this has to be designed in such a way the grey water and black water do not get mixed. Unfortunately, in some places we have seen the households have let the toilet waters inside the drainage went for this grey water. This needs to be consciously avoided, and IEC is to be taken up to encourage the Gram Panchayats so that this is avoided. Next one. So coming to the last part of it, the third party inspection. This is part of the guideline. It is clearly delineated what are all the works that will be done by the state party inspection agencies and what is the qualification for the third party. That's also given there. Just for the sake of repetition, I'm repeating it here. They have to undertake the inspection along with the GP and the Rural Water Supply Department. They have to inspect both in-village and non-in-village infrastructure. We found in one case, one third-party inspection agency is adopting a sample-based approach for testing and inspection. This is not correct. All the structures have to be tested. Sample-based approach by a third-party inspection is not given in the guidelines, it's not as per the guidelines. So it has to be, all assets have to be, inspected by the third party. Quality control measures adopted at the time of construction should also be, checked by the third parties. There are many states have got material testing labs. Tamil Nadu has got an excellent lab that tests all the materials. The Panchayat Raj department that is giving connection to the house is getting their pipes and their concrete cube tested in the TAD board lab. So please adopt such thing. If you don't have labs, you can enlist labs from engineering colleges or engineering institutes and get it tested from there. And when the third party inspection agencies undertake their work, please also check for how this work is done. There are a large number of machineries are being used. The efficiency of the machinery is also important to complete the mission at the right time. We find that some of the machineries breaks down often. Poor battery conditions are there. The vehicle doesn't start. No fuel availability, unfortunately, when you have to run your, compressors or your other machinery, sharing the other, sometimes the contractor is sharing this machinery with other works, which is delaying the Jal Jeevan mission work. So these things also have to be seen by the third party agencies. Concrete construction, please test your concrete cube. For information, just go to the YouTube. Just a week back, Singapore has made the largest concrete pour. 37,800 cubic meters of concrete were poured in 57 hours. You'll be surprised to know they take water, they test the concrete with an iPad, they take a photograph, compare that photograph with the design mix concrete and say that the quality of concrete is good or bad. It avoids the human intervention during this corona period. So such is the level of advancements we have. I don't know whether we have it in India. I tried to do a Google search, I couldn't get it. But Singapore has done it. It is available in the YouTube video. Please have a look at that. It's really very good. We have a large number of non-destructive tests available for testing our existing assets, especially the rebound hammer method for your concrete testing. Many of our institutions have this rebound hammer test and other concrete tests. This is part of the civil engineering curriculum nowadays. You can use those assets for testing the life of your existing assets. Next one. Quantity of the works to be executed, it should be as per the DPR and estimates. You all know I don't have to say this. Safety measures to be adopted at the time of construction, especially when people are working in elevated areas, elevations, both at top as well as at the bottom. Ensure that people wear proper hats, so that they don't get hurt when they work at top elevations. Recommendations for the payment of the work also is one of the works of the third party inspection agencies. And functioning of the in-village infrastructure is to be done in the presence of the third-party agency. It's very, very important so that once it is commissioned, there is no complaint from the panchayat that the system is not functioning. And one of the other important aspects is they have to see also whether the payments are made by the states within the 30 to 45 days of time period mentioned in the guidelines, so that the works don't get affected because of non-payment. And one more is, if the state government wants to add any other works to them, it can be added. We have given an open provision in the guideline. So with that, next. So with that, I end my thing here. We are open for any kind of questions and suggestions. May I now request my colleague to take over the next part of the presentation. Thank you very much for that.
बस सुनो, इस तरफ रखो, इसको बीच में लाओ, सेंटर में लाओ, इसको बीच में रख दो, यहीं पे बस यहाँ रख दो, बस इट, बस यहाँ रखो, यहाँ, ठीक है, ठीक है.
Thank you very much, Mr. Muralidharan, for explaining the key engineering principles, and we hope that this will certainly help our engineering colleagues to understand the nuances, and that will help them in planning and proper implementation of Jal Jeevan Mission. So now our next speaker is Mr. Rana Ramesh Singh. So he is the public health engineering specialist. Right now he is heading the national PMU in the Ministry of Jal Shakti, National Jal Jeevan Mission. Now I would request him to proceed with his presentation.
Thank you, sir, for introduction. Murli sir has already given the brief about the key engineering principles, and I will be talking about the planning and design aspects. Concerning time constraint, it will be very difficult for me to cover the entire things because it's a vast area, but I will try to discuss the critical aspects and wherever the gap. So when we talk about the planning and design, it's like an entire process. So we can see that here, like we have various steps, and maybe that I will be explaining each and every step very clearly. So what important things I would like to address here? If we are failing to plan, that means certainly we are planning to fail. So unfortunately, the planning and design development is not given the importance, and which I feel this is very important stage if you want to have cost-effective and sustainable design. So when we talk about the data collections and the site investigation, this is the foundation of the design. Unless until we have the right input, accurate data, reliable data, certainly we are not going to achieve the goal of having the cost-effective design. Population, water demand, very important aspects, because entire my infrastructure cost, what's the size of the tank, what's the size of the pipe, all depends on our accurate population projection and the water demand. Existing infrastructure, that I'll be talking in the next slide very clearly. It's very important aspects. One of the objectives of JGM is that use the existing infrastructure to make our cost-effective design. And how we can use that, so I'm going to talk about all the tools, techniques, process in the next slide. Selection of source, already Murli sir has covered, so this is important aspects. Here I would like to focus, when we talk about the design development, what I see that most of the time, due to time constraint, directly we go for the detailed design. So my suggestion will be that let's go step by step. In the very initial stage, let's do the very conceptual planning. What kind of a scheme should be there? Should be SBR scheme, NBR scheme, what kind of source we should select, what kind of treatment we should select, because all these planning aspects is going to affect the cost, and we can make like a cost-effective solutions. Always when we talk about the design, our key focus should be on the project life cycle cost, those things. So when we have a different option in the concept stage, guidelines suggest that at least we should have 3 solutions and see that which is my best solution. Not only the capital cost point of view, because when you talk about the project life cycle, what is my capital cost, what is going to be operational cost, and then we decide, okay, what scheme we should take in. Technical specification, cost estimate, definitely once detailed design is done, this also is an important factor because this governs the cost. Most of the project I have seen that there is a lot of cost variations. So here we can control, if we have a good design, good technical specification, we can minimize the variation in the project cost. And once design development done, then we go for the tender. So I will be discussing each next slide, each and every step in detail, and I will show you some tools how we can do in an effective way. Next please. So this is our first step, like baseline data collection. So like in this stage, this is the process. So this data has to be collected in consultation with the various stakeholders. So like most of the time what I've seen that we are dependent on secondary data, like we are collecting the census data, we are collecting the meteorological data, but very important aspects is that validation of data. So whatever data we have collected, is that right data? I will give you one example. I was doing one DPR and we have taken the census data, and when we submitted the DPR, I came to know that whatever the population we have selected is wrong. Why? Because in 2000, we have taken 2011, in 2050, about 50,000 population was merged with the urban area. So it's important that we evaluate all the data. So these are the comprehensive list, very key things I have listed about the demographic profile, like what is my village boundary, what's the population, what's the meteorological data, how my habitation is going to be based, what are the local sources available, whatever design I'm going to propose, whether materials are available nearby or not, what are the local best practices, because this is going to optimize my design. So these things we can have a clear checklist and we can see what is there, what is not there. Next please. Site survey and investigation is very important aspects. Somehow I feel that this area is also gray area, and when we design, not proper importance is given to that, right? So when we talk about the topographical survey, it should have different components. Apart from the contour map, definitely it should have land reforms, what kind of land use we are showing, what are the water source availability, whether it is surface water or like natural stream, or a groundwater sources. Geotechnical survey, this is a parameter which gives us the optimum design when we are designing a structure. Like if I'm designing a pump house, I'm designing a reservoir, what should the optimum thickness of my reservoir wall, should be the optimum design, so that's parameter gives me. This also helps me to suggest what kind of foundation should be there. Most of the places I have seen that reservoir we are designing without any structural analysis, which is not good because it will have a over design, maybe sometimes under design, it may have the proper design life. Hydrological survey, especially whenever we have like a ground-based schemes, this is very important aspects. A lot of schemes, what I have seen that we have designed, very fantastic infrastructure, everything is fine, but whatever the ground borewell we have selected, that borewell is defunct. Why it is defunct? Because we haven't done the analysis that whether groundwater is available, what will be the yield, how long it's going to sustain. So what my recommendation is that we must do the proper site investigation and survey before jumping on the design stage. Next, please. Here, there are a lot of methods for population projection, but what I would recommend that before going for the population projection, certain things we have to keep in mind. Number one, there are certain area, like for example villages, which may be very close to the highway or railway or maybe some industrial area. The population projection for that village will be a little bit higher. So if we go by scientific methods of calculating population by different method, arithmetic method, geometric method, so it's always not going to work out. So we have to apply some common sense that what is the actual ground situation in that particular area, right? When we say that, okay, now we have to do calculation, always calculate the population, one for the base year, which will go to what time project will be completed. At the same time, intermediate year for 15 years and the ultimate design. Now, why we need for 15 years? A lot of people ask the question, why we are designing a system for 30 years, why we should go for 15 years? We design population for 15 years because there are certain components in the design, like for example, I will say the pump or electromechanical equipment, for their design life is only 15 years. So unless until we know the population and demand, how we are going to design that. Second part is that this also helps me to plan. If I'm designing my system for 30 years, why I should design my treatment plant for 30 years? Why not design on the modular basis? So I can save my cost. So I can design for entire 30 years, but what I can do for next 15 years? Similarly for reservoir, it doesn't require to be for all 30 years. So we can do in phase wise. So this also helps me to plan, okay, how I'm going to construct the different components of the water supply system. Coming back to water demand, this area is, I think, also a lot of confusion is happening on the site. Some places, they are saying that 55 LPCD we will design. But when JGM talks about 55 LPCD, is the minimum at the consumer end, not at the source. And when we are designing the water demand system, apart from the household, definitely we need to consider about the institutional requirement. In villages, there will be different schools, there will be Anganwadi, there will be public buildings, a public health center. So we have to consider the water requirement for those buildings also. Other important aspects, livestock. A lot of DPR I have seen where they haven't considered the requirement of the livestock. So first, we need to understand the village profile, what kind of livelihood they are having. Some villages I have seen that the livelihood, there's no dairy system, or they are having the cattle, very hybrid cattle. And the cattle requirement is sometimes, I was quite surprised to know that one cattle requires sometimes 100 liters water per day. So unless until we have considered those livestock requirement, our design is not going to fulfill the purpose. And then losses. When we are designing a system, most of places I have seen losses happening 30%, 40%. But at least when you are designing a system, at least consider 15% losses for the water demand. So considering these all factors, we have to design a system that what should be my water demand. Next, please. This slide I would like to explain. This is a very typical rural water supply scheme, and I have tried to show the different components. When we talk about it, start from source. Source can be either groundwater or surface water. that we have to decide depending on the availability of the water. It goes for the treatment, and after treatment it goes to the overhead tank, and those go to the different village area. Now think about the examples, like suppose we have the plain area. So designing the system in the plain area is much simpler because the levels are same. But what problem we have occurred on the site, that we got to know that we have the system, we have the network, but at the tail end, we are not getting the water. And what could be the reason for that? Maybe that while designing the system, they may not have considered what should be my minimum residual head at the tail end, and accordingly, the staging of the OST should be there. So some places, they design the height of a overhead tank without considering the network design. So that's not happen. So first of all, we should know that, okay, now how my habitation pattern is there, and if I want my flow and pressure at the end point, what will be the minimum requirement of head? Accordingly, we should decide the head, right? So in shortcut, what some places they have done that, like, okay, now I have placed my tank, and since end point water is not reaching, so directly they are getting separate pipeline to that connection. So it's not the optimum design. So ideally, as Murali sir has also explained, that if it is a plain area, always preferable to place my OST in the center, so that whatever habitations we have, almost we have the first thing, your pipelines will be shorter. Second thing, that every household, they will get the equitable water with the flow and the pressure. That's the first concept. Now, there may be some scenario, especially in the hilly terrain, that in the same village, there is huge elevation difference between habitation. Even I have seen in some states in the like Himachal, level difference in the same village area, community area, is up to more than 50 meter, somewhere to go to 100 meter. And same problems, what happens like if you are giving the common overhead tank and if you are supplying water, chances are that the habitation which is at very low level, they have maximum head, they will get the water, but the habitation upper level, they are not getting the water. So what should we do for that? In that case, we have to plan that, okay, now, depending on the topography area, we have to do the zoning of the area. We call it hydraulic zoning. So maybe that's like a top, what I have shown, zone 1, that's the higher elevation, and the bottom we have shown at the lower elevation. So I'm designing separate system for the high elevation area. I'm putting my separate reservoir, and then we can have a distribution line. The area zone 2, which is lower elevation, I can't use the same overhead tank because overhead tank has been designed for high pressure. So we are breaking the pressure so that pipe gets the right pressure and the flow in the working area. There may be some habitation in third part, you can see that, which is isolated remote area. So I have designed separate system. Let's have like a solar-based system, something like that. So what I'm trying to focus here, that rather having centralized system for entire village, let's have, depending on the topography and the habitation profile, we can have the decentralized system. And while planning the water supply system, definitely we must consider the cattle trough, your washing guard, that's also important factor, right? So this is about typical village. Now suppose example, if you are designing a multi-village scheme, so our approach will be different. So like suppose if you have a source and from we are supplying different villages, so what the concept we can have a zonal balancing reservoir system. So we can have a group of villages, we can divide in one group, there can be separate zonal reservoir, then can be other villages which have separate zonal reservoir. If from mass balance reservoir, if you are planning to connect 8 or 10 reservoirs, it's not going to help you because we will not get the adequate flow and pressure. So first from mass balance reservoir, it should go to the zonal balancing reservoir, and from there we have to supply different village group to keep the objective of having the equal pressure and the flow at every point of time. Next, please. This is an important slide, and this slide I prepared based on the feedback. Most of the places I visited that I was getting the feedback, it's not possible for me to give the last mile connectivity. It's not possible to do my retrofitting scheme, right? So I have tried to explain here, like one scenario could be that we have one village where we have adequate quantity of water. You have designed the system, few houses are left. Now question is that whether we can do the last mile connectivity or not. My answer will be why not? First thing, if my scheme has been designed, suppose in the last 5 years or 10 years, right? So that means system has been designed for the next 30 years. So still that system has life of more than 15 years left. Other problems, what is happening, especially in the rural area, our demand is less, and we have criteria of having minimum dia of the pipe. So what is happening to meet the entire water requirement, the velocity in the pipeline is very less, 0.2 meter per second, 0.3 meter per second. So what I'm trying to say that the existing infrastructure, what we have created at site, that has higher capacity to take the demand, additional demand. So if already my pipe has been designed higher to have more capacity, why we can't give the last mile connectivity? So it's very easy to connect it, right? It's very easy to find the pressure and the flow at the end point, and if you are getting adequate flow and pressure, very easily we can collect to the last mile connectivity with a very minimal cost, without any redesigning, without looking at anything, right? Now, this is a typical case. I have tried to put the different scenario. There may be that there are existing sources, and that sources may not be sustainable for long term, right? So then I put the arrow, like if it is S, directly we can go for the design purpose. Suppose if source is not sustainable, in that case, we have to augment the source, right? If we can have additional bore wells, or we can find the alternative sources, right? Or we can deepen the bore well, so that way we can augment the source. Now we are happy with the source. What next? Now we have to come to the existing infrastructure. So I will analyze my existing infrastructure. Okay, this is my future demand. Whether the existing infrastructure have the capacity to take the additional demand. And I am going to replace only those pipeline which is undersized. So suppose you have a network of 5 kilometers. Out of 5 kilometers, hardly we feel that based on experience, 20%, 30% pipeline will be undersized. So if my pipeline is good condition, why not to use those pipes for retrofitting and provide the connections? So that's the flow diagram I have tried to keep you like, okay, now how the process wise, step by step, we can go that. Next please. This is the, I think, hydrogeomorphological map. This is already available on the website. Anyone can download. This gives us idea that in particular area, what is my yield, what will be the depth of tentative bore well, right? So we can superimpose this data on our base map, and we can find out about the groundwater ability. But I would recommend wherever there's a critical area, where you have got, okay, now groundwater is depleting, definitely we should go for the hydrogeological testing. There are a lot of techniques available, vertical electrical sounding, which gives us idea what should be the yield, what's the depth of bore well, how long it's going to sustain. Next, please. This is the checklist. We try to prepare a very simple checklist. So if I want to have source, this checklist gives me that what is the water source ability. So like the different source, surface source, groundwater source, and other source. This is the last point. You can see that I have also considered rainwater harvesting and the grey water reuse. In most of the area, in the water scarcity, this is very important aspects. So this is the checklist gives me what are the total amount, whether in all the seasons this water available, what's the quality. Based on that, we can take the decision how I should go forward to strengthen or augment my source. Next, please. This GIS map team, I think this is the area where we need to focus now, right? So right now, especially for the retrofitting scheme, I get the feedback. I'm not aware that how my existing pipeline is going on, right? If we try to capture the whatever my existing pipeline on the GIS map, this is going to help the problem. I will give you an example. About 10 years back, I was working on a UK project, and I was given the task, okay, now we have a system, and now I want to retrofit this area, and we need to do in 1 month time. I was quite surprised to know how we can do in 1 month time. But I was said, okay, I will share you the data, and I got the data. Client has a beautiful system of everything was in GIS map. By click of button, I could know that what is my pipe dia, what's my pipe material, when it was laid. So entire information, what I wanted for design, that was available in the GIS map. So if we are not doing the GIS mapping right now, even if I'm going after 20 years, 30 years for redesign, again, same question will arise. So what strongly I will recommend that we must have GIS mapping system for each and every asset, which is going to help in long run. It is going to help you if you want to do the, again, redesign. It is going to help you for the asset management. It will help us for the preventive maintenance. So a lot of advantage we have using the GIS map. Next, please. These are the, I have created like this tool for the infrastructure gap. So the very simple sheet which shows that what is the current status, like what infrastructure capacity I have, and what is my future requirement. See, if I'm designing for next 15 years, 13 years, what I need, and then what I have right now, and what is the conditional of that statement. So if we have three factors, then very easily I can decide to how much extent I can use my infrastructure and what additional infrastructure required. And that way it's going to help me to optimize the cost. Next, please. Design period. Here I have put like a design period. You can see that except the some electromechanical equipments, we talk about the pumps, we talk about the electromechanical part of the treatment plant, my entire infrastructure, whether it's a pipeline or reservoir or water treatment civil work or pump house, that have the life of design period 30 years. So when we design a system for 30 years, and this I'm talking about the design life, the service life, if we are going to maintain this infrastructure, service life will be much more than the design period. Even like nowadays we are using the SDP pipe, they claim that life of the SD pipe is more than 50 years, somewhere it goes to 75 years also. Same way for all the concrete structure about the reservoir also, right? So we should have the design period for minimum 30 years. Next, please. These are some design criteria, as this is a well-known factor. So here, only things I would like to focus here about the minimum velocity. So when we want to design my system, optimum 1 meter per second, you will get the optimum designs. About the pipe cover, I think this is the gray area. So most of the places I have seen that pipe cover is not sufficient. So minimum we have to keep 1 meter pipe depth and residual head. So while designing, keep all these factors in mind for optimization purpose. Next, please. Pipe material selection. This depends on, again, it's a vast area, depends on a lot of factors like what's my ground conditions, then your hydraulic efficiency. So nowadays the trend is that most of the time we use the MDP, SDP pipe. The reason is that first thing, it has long life and non-corrosive, better hydraulic efficiency, and we can join seamlessly by fusion joint. Doesn't require like a those kind of like a flange joint, other things. So it can minimize the leakage also. So especially on the area when you are plain area or those, we use the SDP pipe. So many places I have seen the PVC pipe. So I will not recommend the PVC pipe. The reason is that it doesn't have long life, and if it is exposed condition, it brittles very shortly. So try to avoid the PVC pipe. Next, please. Especially in the rising area, which require the high pressure, definitely we have to go the strong pipe, which has the more resilience and strength. So we'll go for the DI pipe. And the cold region, maybe pre-insulated pipe, we can use that. So these are very broad criteria for the pipe selection methods. Next, please. Now coming to the design part. So till now we have done the baseline study, the survey part, what kind of material we have there. Once we have finalized all basic parameters, then we go for the design. So nowadays there are a lot of technology are available for design part, and what I would recommend that certainly we should go for the 3D surface model for designing. So this helps me to know that what's my ground profile. By color we can know that okay, what elevation will be there at each point node, and this can be exported to our different software for the hydraulic modeling, which I will discuss next slide, please. So this is a typical hydraulic modeling. So once you have fixed the design criteria, we need to optimize. As I was discussing earlier, I want my adequate pressure and flow. So we can play with the different, changing the dia, what should be my velocity, what should be my head loss, and we can optimize the design, and which can save a cost a lot. So we have done the analysis, some projects like if I'm going from manual design without optimization, and once we go for hydraulic modeling, at least I can save my cost to 20%, 30% by using the right hydraulic modeling techniques. Next, please. Here I would like to focus here about the pipe laying things. Like as I mentioned that we should provide the minimum 1 meter cover depth. Some places it may not be possible to give the 1 meter cover depth. So I would recommend in that cases we must go for the pipe bedding calculations. There are IS codes that gives you, okay, now this kind of pipe material you are using, what should be the minimum pipe cover depth? If it is going to sustain, it's fine. Otherwise, you have some preventive measures. So if we have very narrow space, we don't have a space to lay deeper, definitely we can protect by putting a slab cover on that. Especially in the rocky terrain, some places I have seen that pipe are laid, even SVP pipe, and there is some point load, it's going to fracture the pipe in long run. So always recommend give some sand bedding so that the bedding is smoothened and pipe laid smoothly point. Next please. These are some examples which I have captured on the site. Like you can see that pipe is exposed and vehicle tire is on the pipeline, so it can damage the pipeline. Right side we can see that the pipeline for the house connection has been laid in the road and it has been put exposed. So again, it's going to damage the pipeline. So what we suggest that in that case area, even if it's not possible to cut the road, simply we can have a very mild hump in that pipe is covered. There is encasing, so that we can increase the pipeline. Some place I found that even PVC pipe is exposed along the road. So it's not going to have for the long run. So we have to take adequate measures to prevent this kind of problem. Next please. Now I am talking about the water treatment. Again, I'm not going to detail. Just very briefly, I have given like different techniques are there. Depending on the water quality parameters, we can select the right technology. Next please. So while selecting the different technology, I have put certain parameters like how, suppose for same removal, we have different technologies. What technology I should use? So this will depend on various factors. It can be what is the space available, what kind of quality we require, what will my capital cost and operation maintenance cost, life cycle cost, and based on that, we can take the decision what kind of treatment technology we should select. Next, please. The other example I found during the site visit that you can see the treatment plant doesn't have the weir. So definitely when you design the system, make sure that we have the proper design done. It helps in the controlling the flow, it helps in the proper sedimentation. So unless until the properly designed system is not going to work in an efficient way. Next please. Pump selections, normally we use for the submersible pump where you need the high head pump, centrifugal pins normally in the ground surface, those things. Turbine pump wherever you need the high head pump, and solar pump wherever there is electricity problem in remote area. But one thing here I would like to highlight here, please try to avoid the low discharge and high head pump because this has low efficiency. What we can do in that case, we can reduce the pumping hours so that discharge rate and we can get the maximum efficiency. And always we should prefer to use the energy efficient pump. Here what we should do, once we have designed based on theoretical, okay, what should be my discharge and head, and you select the pump capacity, always consult the manufacturer. They will give you the best design depending on the system curve, what should be the optimum design for the pump, those things. Reservoir, this also I think this is one of the gray area designing. Reason is that some places during the field visit what we found, reservoir over design. Our requirement for the designing is very less. When we are designing a mass balance reservoir, depending on the mass curve, we can design the optimum capacity. Hardly a mass balance reservoir requires me 1 hour, 2 hour retention because water is coming and flowing. When we go for the service reservoir, provide the half day storage requirement. Reservoir must have some level indicator so that at least we can control the flow. Whenever water gets empty, water can be filled out, those things. And as we have already discussed, that if you want optimum design, do the proper structural design. So nowadays we are designing on thumb rule. Okay, we are designing those things, so we have to avoid those kind of things. Next, please. This slide I would like to focus here. So far we have discussed about the design, planning and design. And what I would like to emphasize here, if you go in the project life cycle, concept, planning, design, construction, we can see here that the opportunity for reduce the cost is maximum in the concept stage and planning stage. And as we move forward, it's very difficult to reduce the cost. And that's the reason I was emphasizing we should focus on the concept planning so that we can reduce the cost. Those things. Please. About the cost estimate, we have discussed a lot about the design. And if we have very sound design, good technical specification, our cost estimate is going to be right. So when we do the cost estimate, make sure that we have the good design and technical specifications. And again, about the life cycle cost approach, it's not only the capital cost. when we are taking any component, see that in the long run, considering that design life of 30 years, what will be my cost? And based on that, we should have selection of those things. Item rate is well known to us. Most of the states we have the SSR rate. In case we don't have, we can use the market rate to determine the cost. And when we calculate our per capita or FSTC cost, just see that what is the benchmark, whatever cost I'm arriving, is that aligned with the cost, what it should be optimally. So every state, they should have their own benchmark. Okay, now if I have this kind of terrain, this kind of profile, what should be my optimum cost for the FSTC cost? And based on that, we can moderate the cost. Next one. This is my last slide. This is not the technical slide. So just ASR has already highlighted about the transition. So now what we are trying to convey here, like we have come from asset creation to the service delivery. So earlier, our role was mainly to just create the infrastructure. I'm designing, I'm providing the tank and the pumps and etc. But what is the purpose of that? We are serving a big role, and it's a great responsibility on us. So as a public health engineer, our responsibility is not only to provide the water, it's providing the safe drinking water. Because 80% of disease is coming from the waterborne area, and especially rural area. Unless until they get the pure drinking water, it will be difficult to improve their health. So we have great opportunity to improve the health by providing the safe water. Now, the next stage of the public utility is not giving the water quality, safe drinking water. We have to understand the customer need. So our approach has to be reversed. So we are like a service provider. So what our customer wants, what kind of service delivery we can do that so we get a smile on their face. And most important thing is that focus on self-sustainable. So whatever system I'm designing, is that going to be self-sustaining in long run or not? Again, I would like to share one example, one of the international projects I was working. How the concept is that regulator agency, they conceive a project and they invite different service provider. This is my service level KPI. So I want this much quality, I want this much quality. Then if there are repair maintenance, I want to get repaired in this means. And then they ask, now what optimum cost you can provide these services? So there is a healthy competition between the different service provider. And how the model works, if I have given to one service provider and other service provider, and if the performance of other service provider is better, always there's a chance that, okay, now the work goes to them. So this is like they feel like, okay, I'm part of the community. I'm trying to give my services in the optimum way. So just is a thought for everyone, why we can't go for similar kind of approach here? How optimally we can design the system. So with that, I would like to conclude my presentation. I will be happy to take any question at the end of the session. Thank you very much, sir.
Thank you.
Thank you, Mr. Rana, for the beautiful presentation. So before we go to the last presentation, I have a small announcement. So all the presentation, PowerPoint presentation we have for the webinar today, so that will be uploaded in our JJM portal. So that will be beneficial for all the stakeholders. So our last speaker for the day is Mr. H. Hingurani. So I'll request Mr. Hingurani for a brief presentation considering the time constraint. Mr. Hingurani retired as Chief Engineer Engineer in Chief of Chhattisgarh State. So I'll request him to proceed with the presentation. Mr. Hingurani.
Thanks me to giving an opportunity to present my some experiences I have carried out in the few states. Good afternoon, everybody. Additional Secretary, sir, has already given a strategy regarding AJM. He has very categorically stated what is needed from the public health engineers. Really, it is a challenge. So, hence for the successful implementation of the JJM program, my humble request to all public is to be a social engineer. Repeat, be a social engineer and try to adapt new skills and innovative ideas with respect to your site-specific requirements. Not go for what is given in the guidelines. And I'm thankful to Mr. Muralidharan and Mr. Rana. They have given an excellent background regarding engineering practices. So my first presentation will be coming on the drinking water source security and sustainability, how to achieve it, and regarding planning. Basically, a lot of things have been talked on the platform. Basically, what I consider source is a source can be termed as a soul of any drinking water supply and needs a sustainable source. So, key requirement is a source sustainability, as you are looking there, and object is basically I am talking because 95% schemes are based on groundwater based sources, right? And I need to ensure how to ensure the groundwater source sustainability and security. And basically my aim is to improve the water table, enhance the yield so that my sustainability may continue and improve the water quality, because with the depletion of groundwater, water quality is also deteriorating. So basically, how the what are the key factors of the source sustainability? See, I need a quantity, which was explained by Mr. Rana. I need a dependability, which Muralidharan has told. If minimum 90% dependable source is required, I need a quality assurance. BS 1500, safety. Safety is that my source are not to be contaminated, and security is most important. So I can attain the sustainable source. This is a basic background needed for the planning. Next. So need is to ensure drinking water. I am not talking, it is already talked. The solution here, I am coming back. This is based on case study we are suggesting that it is a watershed unit to be put a water. We are taking watershed as a unit and bifurcate into the village level security action plan to ensure groundwater recharging and conservation practices. Next. So this is basically watershed. This is the one example I am putting, that this was a action plan was developed for the state of Chhattisgarh block Patan. This was project executed with the help of the NRWP guidelines, where we have constructed small dikes, etc. And we have yielded the excellent result. The water level was there roughly 40 meters, and thereafter, now present water level, the JJM task force is seen there, it is only 10 meters. So 30-meter water level and gone up. So this is an example, and basically I am not talking much because the last 2 decades depletion has taken place, and most of drinking water sources are depleting or drying up. Right? So these are the basic planning tools were used. So it is a primary secondary data. It is a GIS platform, as Rana suggests, which is the most important technique for today. So basically these are the data required. These are baseline data required for the planning. You need a district map, block map, topo sheet, and basically 8 GMS, which the ministry has already circulated. And these maps are to be geo-reference only to ensure the layering. Next. So see here, I have taken up one district, one block, and these are geo-references. Next. So here, what it was block pattern, as I told you. So block pattern consists of 4 topo sheets. These are surroundings available. I only combine them, and similarly 8 combined your reference for that block. So these are the soil conditions are there to ensure water, whether my soil can infiltrate up as permeable to ensure groundwater flow. Next. So basically this is based on the my topo sheet areas, I have delineated the watershed among that block, and based on the I have considered only three things here. I don't know whether my area is rechargeable or not. Number one, soil. Number two, geomorphology. Number three, structural geology. So once my conditions are okay, so my area is rechargeable, I should have to proceed further. So this is a planning process. Here I have taken the village gram panchayat data, village level mapping of institutions, what already was suggested, mapping of the census data also, agriculture detail, mapping of livestock, etc. Next. So immediately all this data has been covered, what is the forest covered, etc. And ultimately land use pattern has been derived from the satellite data. Next. So basically these are the mapping of the data is given. One is village level, then a gram panchayat, then an institute, water institution available, what we are planning for, and then we have gone for the exactly village level water, drinking water sources there, then licensor, and with that background, all the mapping has been carried out on the GIS platform. Next. So these are the data taken from the remote sensing NRSA. One is the pre-monsoon data, one is the post-monsoon data. So that will indicate what is the present status, the project which we have identified earlier. Next. So based on that, we identified that what is the land use pattern there. So it is a very plain land, and it is not coming the forest area. So it is a revenue land. Based on that decision, this is a land use pattern that will be derived from. And based on that, now we are going to develop a decision-making thematic maps. So basically, it is a drainage map. We need a contour map, physiography, zoning, slope, soil texture, and geomorphology map and lineament, which is the most important thing. Lineament, fault, fissure, or geology is going to play a major role in recharging. So based on that, we have developed this drainage map, then physiography map, zoning map. These are the one platform in that background, and it is a 10 meter resolution. We are taken the data from NRSC. So because it is on the 10 meter resolution, this is zero. Again, we have brought back here. You see here that these are the lineaments. Fault and fissure which I am showing to you. So lineaments are the most important points where recharging can take place. If I am putting a structure on that lineament or fault or fissure or geology, this is going to be excellent recharge points. Next. So now I have developed an overlay system. Based on that, now see here, I have overlaid the lineament over the drainage system. Drainage system, what are nalas there, where I have put a lineament there, so I can put the example that this lineament is running across or along the which nala, so in the downstream which structure is required. This is detailed geology. So again, I am putting an overlay, see here. So with putting that overlay, now geology has been overlaid because I know what is the geology. In the most part of the area is a shale, which is not a rechargeable, but my soil condition and soil structure and excellent linear, 48 lineaments are there, and 4 or 5 faults are there. So this is a rechargeable area. I have proved it. Next. So as per Jal Shakti Abhiyan guideline, 3 conditions have been given. Number 1, try to use the existing defunct dugwell tube wells for the recharge. Number 2, I have to go for the existing water bodies which may require a desilting, dredging or clarification so that I can use it. And third one is identification of structures. Based on this theory, so we are the 3 action plans have been proposed. One is for the defunct tube wells. One is for the desilting, dredging, and renovation of the existing water bodies. And third is a new structure. And fourth one is a afforestation in the forest area. So these are 3 action plans that has been developed. Next. So based on that, now whatever structure identified, I have put on the Gram Panchayat level. Even we can identify on the village level action plan also, or we can go as a watershed. So this decision we can take. This is I have done it on the Gram Panchayat level, our watershed action. So these are small structures. This is one a different tube-based recharge pattern. Second, initial, because mostly in the watershed you will find that the initial patch has a higher slope where velocity is high, so I have to control soil erosion. You need a soil treatment. You need a small structure to control the velocity to ensure that my soil is to be saturated, right? And finally, different type of matrix has been prepared how to identify the structure in the watershed and can be combined with the village action plan. Thanks. My second presentation will be coming up on solar water pumping system, right? So basically, this is a most cost-effective technology in the country, and in Madhya Pradesh, Chhattisgarh, almost more than 50,000 systems has been involved as per guidelines of the NRDWP. Maybe, and the solar water pumping system, technical specifications are much needed in the country based on the requirements of the drinking water supply, and past action for last 6-7 years suggested guidelines has been enumerated here. I am not taking much time. Basically, it is a key requirement is a solar radiation, because our country has an excellent solar radiation, more or less, maybe plus 5 hours, maybe even Gujarat, Rajasthan, Bharat, Madhya Pradesh, even 6 hours. So here, the guidelines suggest that the small schemes in hilly terrain, small, because in the background, what studies I have gone from the ministry that roughly 75% habitation are having less than 500 population. Hardly where water demand is there, hardly. Even if I am considering the population of 200, 300, I need only roughly 20 to 25 LPD of water. Right? So in that case, if I have source, what Murli Dharan has earlier told, that with the given central government data, I can ideate safe and sustainable source. Immediately, these schemes can be implemented in the shorter plan period of even 20 to 20 days. And see, here I am putting a vision. What the Honorable Prime Minister says, one sun, one grid, one world, one grid. So government has really taken a challenge to ensure the solar systems. Next. So in brief, I am talking, we need a village habitation data. What is the name of village habitation? Basically here I need a specific latitude, longitude, because my solar radiation governed. Secondly, I have defined basically mostly these are groundwater bases I am talking, not necessarily. We can adopt for the multi-layer systems or bigger village scale, but in the background, I have talked that less than 500 population covering and 75% can be covered habitation. So I am assuming groundwater sustainable source for the 20 years. Based on that, I have put the things accordingly, and I have put the stages in consideration the pumping system as a 10 years life. So my solar life has been considered at 20 years plus. Okay, but I am planning to design a system only at this stage for 10 years. I can augment that. My life of pump is 10 years. I can augment to pump at next stage. And solar panels can be added accordingly at that stage. So this will put a planning guideline as per my experience. Next. So this is I have given a component details. Source is there, pump house is there, panels are there, households is there. So basic planning consideration, we need a location. I need a required shadow-free area. Please keep it in mind. In most of cases, this is not happening. And placement of the panel requirement is in the south direction with the latitude of location. It is because on the latitude location, my sun rays comes at 90 degree. So I had calculated for size of radiation. This is a monthly radiation. In the drinking water system, my requirement is I had to adopt minimum solar radiation, but I had to put the water supply 365 days. So my adoption is from this, my adoption of solar radiation at minimum level, designing for planning designing. So now I am coming back to the next slide. So I am not talking going much on a demography, already Rana has explained. Next. But so clearly here I have to see that my source is sustainable in consideration with the solar radiation hours. Studies suggest, I have seen few DPR from few states that they are trying to adopt pumping hours as 10, 12, 15, 16, but my pumping hours will be equivalent to the PSH. Next. So I need not talk on the conveyance of main house system, already Rana has defined it. Next. So here, see here, for planning purpose, I need a quantity and head. So this is engineering practice. Here total design head. Here there will be two conditions. Minimal radiation level I am getting somewhere in August, and depleted condition of water is in the month of May, June. I got a two set of kinds. Here if water is depleting, my head is increasing, and discharge is also depleting my, but here my head is also increasing, and so accordingly I have to go about the needed conditions, because here I am getting less PSH, here I am getting less season head. Accordingly, engineer has to plan. Next, this is a practice. This is books from books. This is exam. Next. So required. This is required in the external World Bank studies suggest in the Bihar and UP, most of pumps used to get choked or abrasion has taken place in the impeller of the pumps. So naturally, I need to ensure that the pump material should be of appropriate quality. I suggest that it may be of the SS grade 316 rather. This is my suggestion, which I will study. And next, and most preferably, I used to suggest DC pump, because DC pumps are having higher efficiency in comparison to the AC number one, and I am getting the DC power from my panels, so my cost optimization will be there. And again, for the panel sizing, site-specific requirements are needed much more here, right? Losses may be like if I have designed a system, I get an input motor size say 1 horsepower, maybe 0.74 kilowatt. By Thamba rules, the consider losses of the site specific, maybe a cable losses, maybe a soil losses, maybe a temperature losses. Average planning design suggests multiply a pump input to losses, say 50 to 55% for the DC pump motor, 60% you can get a panel sizing straight by Thamba rules. And I have depicted a picture, what I was talking, that south-facing panel and latitude is the minimum requirement. And we should ensure that my quality of panels is A grade. It should be in quality of next. So simply only one thing I am asking the lady viewers defined in the MNR guidelines, only structural zinc coating shall be 120 micron, not 80. So storage, as here only already Rana said that 50% is taken. Here I have to add one thing. For the cloudy period condition, maybe the 30-35 days, I have a buffer storage, minimum for 2 days for 15 LPC per day. Next. So this is an example. I have shown the buffer storage and more storage. And here I am showing one thing very clearly, is a disinfection system developed by Neary, very costly. hardly costs you 200 rupees, and filling cost can be done local. This is a moist sand filled in the container, and bleaching powder, and this is a yellow color showing we hang this system there, and in the Chhattisgarh this is functioning very nicely. So hardly has a cost. This disinfection system is there. So I am not talking much on distribution system. Already fencing has been given the guidelines of NRWP letters, warranty as per MNRE, and annual MC is required to have a minimum 5 years for the as per MNRE guideline. So this will help in community, and preventive maintenance panels are required to be cleaned at least 2 months. Inspection are required as per MNRE guidelines. Next. So I am putting one example here. My population is 250. My water demand is roughly 20,000 LPD. There may be questions that in one source I have got a sufficient yield, but in other habitation, if I am not having sufficient yield in that, only I need to put an additional pump. My panel size is almost same because my horsepower will be reduced. So I am considering 2 sources there. So I am covering that system with that condition. Next. So this is example. This roughly 5 horsepower system was installed in Madhya Pradesh near Bhopal, having panel size 8 kilowatt. This is maintained by the community itself, and they are charging 100 rupees per month and getting revenue of the 10,000, and O&M per month is hardly 6,000 that they are earning that. This is one example from Chhattisgarh. As per new guidelines, this is 6 meter staging tank, 5,000 liter, and this especially this one scheme has been launched by the Chhattisgarh for the livestock. It's called Gurua. So they have put one system of 6,000. All the roughly you say 600, 700 livestock are placed there. This is a daycare livestock condition, and 20 houses are given the water. This is one of good reason. And I have suggested during the visit of the JJM task force, myself and Mr. Jain, who was additional secretary, suggested Madhya Pradesh PS that there is one multi-village water supply scheme having O&M cost of 6.5 crores, out of which I am electricity charge of more than 4 crores, sir. So if I put a grid type system there, I can get a 0 bill of electricity, and ultimately this is going to be a sustainable system. Next. So this is one case Punjab is there. We have put some remote monitoring system. This is also backup of this system has been supported by solar. Because if the remote monitoring system, I need a battery backup to ensure that functioning of remote monitoring system. Next. This again, this system has been installed. This IRB. Again, this system is supported by the solar system, and mostly these systems installed in the population is having 300 to 400 souls, so functioning nicely, and this technology has been approved by me. Thank you.
Thank you, Mr. Hingorani. Thank you for the nice presentation. Mr. Hingorani was speaking from his long experience in the public health engineering. So right now we are having few of our engineering colleagues who are connected through interactive nodes. So can I have Miss M. Kavita, Executive Engineer, Kanchipuram. Kavita, are you there?
Yes, sir.
Yeah, please share your experience, or you want to say something?
Yes, sir. I'm Kavita, Executive Engineer, RD Department for Kanchipuram District in Tamil Nadu. With respect to Tamil Nadu, for sustainability of sources, the emphasis has been given for the restoration or rejuvenation of water bodies in our state. And many of the schemes has been converged, like Kudimaramata, State Finance Commission funds and NREGA funds for restoration of water bodies. Also, channels leading to the water bodies have been restored, and check dams with recharge pits have been constructed under NREGA funds, which adds to the groundwater recharge, which acts as groundwater recharge structures. And with actually we had good rainfall under this monsoon, and we have harvested most of the water there. And I want to mention that this our Kanchipuram district have opted for 100% saturation this year itself in the state. And next planning is in the area of grey water management, where we have converted the funds of NREGA for constructing individual soak pits and community soak pits, and wherever possible, a little larger models like vertical filters and horizontal filters also. And the 15 Finance Commission funds will also be utilized for the grey water management. And with respect to JJM and for disinfection, arrangements have been planned for using electrochlorinator, that is which is based on common salt. So liquid chlorine will be pumped into the pumping main so that the 0.2 ppm will be maintained uniformly. And during the visit from Government of India, they have actually directors have suggested for use the abundant solar energy available and to adopt solar power pumps. So from this webinar also, I came to know about the solar pumps from this technical session, and I'll surely adopt it in small habitations, sir. And after we complete it, we'll share it to the ministry. So we'd like to thank the ministry for arranging this technical webinar for finding solutions to the various problems we are encountering in the field. And this serves as a platform for learning the various good practices practiced across the state, sir. Thank you.
Thank you.
Thank you, Kavita, for sharing your experience. Can you have now Mr. Sunil Udia, Executive Engineer, Indore? Mr. Sunil?
सर नमस्कार, मैं सुनील उदिया बोल रहा हूँ, एग्जीक्यूटिव इंजीनियर पीएचई इंदौर मध्य प्रदेश। हम लोग यहाँ पे जल जीवन मिशन एसीएस सर और ईएनसी सर के नेतृत्व में बहुत अच्छा चल रहा है और बहुत अच्छी प्रगति है। हम लोग अपने इंदौर जिले में मार्च 2022 तक हम लोग कंप्लीट करने का हम लोगों ने लक्ष्य रखा है और कोशिश कर रहे हैं हम लोग उससे पहले ही कंप्लीट कर लेंगे। हम लोग फील्ड में जो काम कर रहे हैं तो हमें नई स्कीम्स में तो करने में कोई ज्यादा दिक्कत नहीं आ रही, लेकिन जो रेट्रोफिटिंग्स वाली स्कीम्स है उसमें हम लोग के एरिया में, मालवा एरिया में, इंदौर एरिया जो मालवा एरिया में आता है, उसमें अधिकतर गांवों में कंक्रीट रोड्स बन चुकी है। तो जो हम लोगों ने 10 साल 15 साल 20 साल पुरानी जो स्कीम्स के अंदर पाइपलाइन है तो उनको रेट्रोफिटिंग वाली तो या तो हम लोग वहां पे डाल के फिर से कनेक्शन करना पड़ेगा या उस पोर्शन में हम 100% कनेक्शन नहीं कर पा रहे।
Thank you.
सुनील, आपका वॉइस ब्रेक हुआ, हम आपको बाद में कनेक्ट करते हैं। नेक्स्ट वी हैव मिस्टर बिजित दत्ता, एग्जीक्यूटिव इंजीनियर बरपेटा, आसाम। मिस्टर दत्ता।
Thank you, sir. Good afternoon, all the respected attendees. For introductions, I am Bijit Datta, the Executive Engineer of Barpeta PSC Division in the state of Assam. Although we are facing multiple issues going ahead with the mission, sir, I would like to bring to your notice a few critical issues on it. Number one, the river Brahmaputra is flowing across the state for a length of about 1,000 kilometers, having many soil areas along its border banks. Barpeta district, along with some other districts in the state, is facing acute challenges to make suitable planning to provide FSTC to these soil areas. In our district, there are 464 habitations from 142 villages, sir, out of 827 total villages in the district. Total household of these habitations are 39,210, having population more than 2,10,000, sir. Pipe water supply scheme is not at all feasible for these villages, and average high flood level in these areas ranges to 6 to 10 meters. Standalone solar operated water purifiers are also not feasible for these villages. Moreover, Due to the large-scale erosion by the river Brahmaputra, the villages are shifted to other newly formed sensors. We are in search of suitable techniques to provide FSTC or to provide potable drinking water to the villagers. Number two, sir, Bogota district along with some other districts in the state are having large number of arsenic affected habitation. So we are designing PWSS from surface source. But majority of the river carry highly turbid water, especially during monsoon. Safe disposal of the sludge from such a surface source scheme becomes a trick to sustain the scheme. Due to the alluvial nature of soil in the river basins and humid atmosphere, sludge bearing beds are not at all effective, sir. Neither we can dispose the residual sludge to any natural water bodies, nor we can dump it somewhere else. Regular disposal of the sludge to longer distances by road carriers, truck carriers, it is not economically viable for a water supply project, sir.
Data, just hold on. So briefly, आपका हमने issues we have listened to you and we have understood the situation. So hopefully within next month we will be sending a team to have a detailed discussion and a ground survey. What kind of best technical solutions can be provided in this scenario? Thank you very much for joining.
Thank you.
Now we
sir.
have Mr. Sasi Shekhar Singh, Executive Engineer, Ranchi, Jharkhand.
गुड आफ्टरनून सर, मैं शशि शेखर सिंह, कार्यपालक अभियंता रांची वेस्ट। सर, हमारे डिस्ट्रिक्ट में दो तरह की स्कीम बन रही हैं। एक मल्टी विलेज स्कीम है जहाँ पे हम लोग को सरफेस सोर्स अवेलेबल है और स्कीम बना रहे हैं सोलर बेस्ड। तो हम लोग जो डिजाइन कर रहे हैं किसी भी विलेज के लिए जो स्कीम है, तो उसमें पर हाउस होल्ड जो कॉस्ट है वो 26,000 से लेके 30,000 तक रखने का निर्देश जो है गवर्नमेंट की तरफ से प्राप्त है। इसमें मेन दिक्कत जो आ रही है सर, क्योंकि हम लोग वाटर रिचार्ज स्पीड में जो है हम लोग को दिक्कत हो रही है, क्योंकि हमारा जो पर हाउस होल्ड कॉस्ट है जो है, अगर रिचार्ज किट के लिए हम लोग प्रोविजन करते हैं तो बढ़ जाता है सर।
Thank you, Mr. Singh. Now we have Mr. Alok Agrawal, Executive Engineer, Bhopal.
गुड आफ्टरनून सर। सर, मैं आलोक अग्रवाल, एग्जीक्यूटिव इंजीनियर, मध्य प्रदेश पब्लिक हेल्थ इंजीनियरिंग डिपार्टमेंट से हूं सर, और मैं यहाँ ईएनसी ऑफिस में हूं और पूरा जेजेएम का मॉनिटरिंग प्लानिंग का काम देख रहा हूं सर। तो मेरे पास पूरी स्टेट से फीडबैक है। मैं सर आपको बताना चाहूंगा कि मध्य प्रदेश में करीब 40% ब्लॉक्स ऐसे हैं जहां पर क्वालिटी और क्वांटिटी का कोई इशू नहीं है पानी का, लेकिन बकाया 60% में प्रॉब्लम्स हैं। तो सर, हमारे एसीएस सर ने, चूंकि भरतलाल सर से उनका डेली कुछ ना कुछ डिस्कशन होता है सर, और हमारी टीम की पर डे कोर मीटिंग होती है, तो सर हम लोगों ने बड़ा अच्छा एनालिसिस किया और कौन से पार्ट में सरफेस सोर्स बेस्ड काम करना है, कौन सी जगह ग्राउंड वाटर बेस्ड काम करना है, ये हमने आइडेंटिफिकेशन कर लिया है, एरियाज का डिमार्केशन कर लिया है सर। और एक और अच्छी चीज हमारे एसीएस सर और ईएनसी सर ने कराई है सर, कि जो विलेजेस, रेवेन्यू विलेजेस 250 पॉपुलेशन तक के विलेजेस हैं सर, उनको आइडेंटिफाई करके हमने स्टैंड अलोन योजनाएं बना दी हैं सर। तो वो करीब सर हमारी 6,500 ऐसी विलेजेस निकले हैं सर। तो उसमें 5 मीटर स्टेजिंग पर, एमएस स्टेजिंग पर एसडीपी टैंक रख के और डिस्ट्रीब्यूशन नेटवर्क के माध्यम से 100% एफएसटीसी का सर काम हमने युद्ध स्तर पर चालू किया, और सर करीब 1.5 साल के टारगेट हमारे एसीएस सर ने रखा है सर। तो मैं ये सिर्फ एक सजेस्टिव बताना चाहता था सभी स्टेट्स को कि इस तरह की प्लानिंग अगर करते हैं सर तो ये काफी अच्छा हो सकता है छोटे गांवों के लिए। सर, समस्या के तौर पर मैं आपको ये बताना चाहूंगा कि जो कुछ हमें टारगेट है सर कि 100% एफएसटीसी हमें विलेज का करना है। कुछ विलेजेस में 5 घर, 10 घर, 2 घर, 4 घर तो डिस्टेंट लोकेशन पर हैं सर। वहां तक नल जल ले जाना टेक्निकली, टेक्नो इकोनॉमिकली फिजिबल नहीं है सर। तो ऐसे गांव में जहां पर 2 घर, 4 घर, 5 घर छूट रहे हैं सर, उनको कैसे 100% एफएसटीसी करेंगे सर, उसके लिए कुछ प्रोसीजर सर हो तो बड़ा अच्छा रहेगा सर, हम लोगों को आसानी होगी सर। सर दूसरा एक और चीज सर, हमने 2019 में जब अहमदाबाद में आपने कॉन्फ्रेंस की थी, हम सभी लोग आए थे, तो हमने आपसे एक क्वेश्चन किया था कि इतनी सारी एजेंसी, आईएसए, पंचायत, पीएचई और सब लोग मिलेंगे सर, तो कैसे काम एग्जीक्यूट होगा। तो सर मैं आपको बहुत उस समय हमें लगा था, लेकिन आपको मैं धन्यवाद देना चाहूंगा कि गाइडलाइन में आईएसए का प्रावधान करने से बहुत अच्छा हो गया सर, क्योंकि अभी गाँव में जब काम शुरू हुआ सर, तो हर गाँव में कॉन्क्रीट की रोड्स हैं सर, चबूतरा से चबूतरे के बीच में कंक्रीट रोड है। तो ठेकेदार जब पहुंचे तो उनको काम करने से रोका गया कि भाई हमारी रोड टूटेगी, फिर रिपेयर कौन करेगा, आप रिपेयर नहीं करेंगे, उनका भरोसा नहीं था सर। लेकिन हमारे लोगों ने जब इन्वॉल्व हुए, लोग गए, हमारे डीसीबीसी गए, हमारे ऑफिसर्स गए, उनको कन्विंस किया सर, तो वो लोग माने और काम आगे हुआ। कहने का मतलब ये सर कि अगर वो आईएसए हम पहले से हमारी इन प्लेस हो जाती सर, तो हमें ये शायद समस्या नहीं आती। अब चूंकि हमारा काम हो गया है, SWSM से भी हमारी अप्रूवल हो गई सर, तो अगले महीने हमारा आईएसए, टीपीआई सब कुछ आ जाएगा, तो कोई दिक्कत नहीं आएगी सर। एक सर मेरा IMIS को लेके सुझाव था सर, कि IMIS में सर जो अभी हमको क्यूमुलेटिव प्रोग्रेस मिलती है सर, तो सर अगर ये डेट वाइज हो जाए सर, कि मुझे इस डेट से इस डेट के बीच प्रोग्रेस क्या हुई, तो सर हमको मॉनिटरिंग और इवेल्युएशन में बहुत आसानी होगी कि हम अपने यहाँ भी रैंकिंग सिस्टम लगा सकते हैं सर, कि किस जिले का अच्छा परफॉर्मेंस आया, किस मंथ से किस मंथ के बीच में। तो डेट बेस्ड अगर हो जाए सर, तो बड़ी मेहरबानी होगी सर। थैंक यू सर।
Thank you, Alok. Thank you very much for your suggestions. So we'll keep that in mind. We have received a few queries through YouTube online chat. One question was that is there any strategy being taken up by Ministry for source sustainability and resource mapping? I would like to request my colleague Mr. Muralidharan to respond to it.
We just would like to say that there is an excellent strategy chapter in the guidelines that actually rolls out a clear way in which the source sustainability would be approached. But three major things I would like to highlight. One is that this captive borewell recharge structures, which were earlier part of this NRDWP 15% sustainable funds, which were actually removed, have now been brought back. So you got some funds available for that. Second thing is on convergence. We have seen a lot of such examples in Gujarat, Tamil Nadu, and all other places where convergence with other schemes, especially MGNREGA, IWMP, have helped for recharge of this groundwater, as was told by the executive engineer from the Tamil Nadu government also. And third one is use of your grey water for your other non-potable uses that brings down your fresh water requirements, which would in turn is actually useful for, you don't have to supplement more and more water, it reduces your demand. So these three basic things, apart from that, a detailed response is also available in the guidelines also. And as far as this resource mapping is concerned, as per in our village action plan, it is important to identify the existing tanks, ponds, defunct borewell recharge structure, borewells for actual recharge, which was so far not happening, and which we have now brought in. And another example for this is even a rainwater which is available with 25 mm. If people could store around 25,000 liters of water, I mean that itself is a big source, right? So that again acts as a sort of your conjunctive use. So these are some of the things, and as a strategy they have already been described in the guidelines also. Thank you.
Thank you, Murliji. We have another question for Mr. Rana, whether any free design software will be available from the Ministry for design of systems. Mr. Rana.
You will be heard. The question regarding design software, so I talked about two components. One component about the GIS mapping. So GIS mapping, we have QGIS software, which is freely available on the web. Anyone can download and it can work out. It's very simple tools, and with few days of training, we can do those things. When we talk about the design software, so since village infrastructure like a very small scheme, limited pipe node, so that we can use the EPANET. And EPANET is also available free on the net. So these software we can help to plan or design for the village infrastructure scheme. Thank you.
Thank you, Mr. Rana. One question is there for Mr. Hingorani. Mr. Hingorani, could you please respond to one of the questions? How can we ensure source sustainability in desert-prone areas?
Basically, what I was talking, most of the cases we have got the HGM maps, right? And if you go through the HGM maps, they are initially mentioned what type of structure can be put anywhere. This is already from NRC decision is making. Only you have to validate the things on the site. And in the desert project, this is possible. I have visited the Kacha Run with a team, village Karanpura, where earlier sources were found failure. But with the putting of 2 or 3 small check dam dikes, now their source has become sustainable. It is a Korea Kacha that is a part of desert, you can say, not a desert exactly, but this is happening there and good practices, and we have got a huge data and validation is required.
Thank you, Mr. Hingurani. So since we are coming to the close of the webinar, now I would like to request Additional Secretary and Mission Director for his concluding remarks. Sir.
Thank you, my 3 panelists. First and foremost, I would like to thank each of them for wonderful presentation, experience sharing, and I am pretty sure that it will be useful to, in some way or the other, to each of the participants. Kindly keep in mind that we have deliberated a lot, and we could have kept a very high-level philosophical discussion. Idea is, end of the day, the real tool, end of the day, in public health engineering are the people who are on the ground, or my junior most engineer on the ground, whether it's a JE or AE or deputy engineer or executive engineer, the field people who are on the ground. And I think we are in one way, as you all know, we believe in building partnership, working together, changing lives. So we are duty bound that whatever understanding and knowledge we have, we should try to transfer it to junior most people on the ground. And all those who have joined from, let's say, NGOs or civil society, other sector, it is equally important that they should also know the thought process. End of the day, it is a village level working. So this particular today's program was designed in such a manner that the person on the ground who is designing, who is implementing, his concern, her concern should be heard. We should be able to sensitize them. What is the philosophy of Jal Jeevan Mission? What is the philosophy of, what is the approach? So I think kindly appreciate that this session, this particular episode of Jal Jeevan Samvad is very much focused basically for doing work at the ground and bringing more and more clarity to everyone and basically bringing people on board. I hope, at least to very frank, in spite of working for so many years in this sector, today I learned few things by the 3 presentations which my colleague made. It was a great learning for me also. So I am pretty sure that that you will be taking some positive. We are putting these presentations on our website. We have to just little bit just do that, this thing. Kindly share with your colleagues. If you feel, use freely this presentation. We are not holding copyright. Please use this presentation and educate your own ground staff. You may like to hold this kind of session with your J, A, D, kindly do it. It will be very helpful if everybody start understanding the same way, the way it has been envisaged, that it has been fed. Friends, once again, thank you all very much. Just couple of very quick announcement that because of 25th December is a what you call Good Governance Day. So please update your data quickly, whatever connections you have. We have already, since last 25th December, last year when guidelines were released, and till date, we have been able to provide 2.82 crore household with tap water connection. As you know, we have to, if we go by our yearly target, if it comes around 3.2 crore. So we are short of roughly 38 lakhs. We have 5-6 days left. I think if everybody goes, in a big way, if we can, daily average I am saying 1 lakh connections are uploaded on this data. But our need is for 6 days, every day 6 lakh data need to be updated. So if you can improve your work and give this campaign mode for next 6 days, data entry is done for household connection, I think you will be very proud member of Jal Jeevan Mission, where in a country in the very first year, 25th December 2019 to 25th December 2020, in 1 year we have been able to give more than 3 crore household connection. You will be part of that huge achievement which you will be proud of. Number 2, similarly, for Anganwadi, school and Ashram Shalas, now we are going to put this data in public domain on 25th of December, on Good Governance Day. We want to bring that transparency. Good governance means transparency. Kindly ensure that data is updated so that this data is done. The third thing, lab coordinate and water quality testing, we are going to put in public domain. On 25th January, we are going to put on 25th of December, we are going to in public domain. Kindly update this data for your district, your division, your area, that should be done. Similarly, in villages habitation having water quality problem, you have been able to provide safe water, clean water, pipe water, if not pipe water, through community water treatment plant. Kindly put that data so world could see that you have been able to provide clean water to your young boys and girls, your future generation in the school, Anganwadi and Ashram Shala. Same is done in water quality affected habitation. We are having a different kind of governance, different kind of system and different kind of So I think kindly use this thing. Do share good stories, 1 page, 1.5 page, 2 page, good write-up with couple of photographs and some details, clearly giving what was the problem, how you did the work, what work was done and what is the result. Kindly share this thing. We want that these stories should be sent to everybody. Your success in your area, in your village, one village, a group of villages, kindly do share. Lastly, please focus on skilling. Otherwise, we all will be in trouble. Skilling for plumber, for electrician, for fitter, for pump operator. I think we have to build the capacity and orientation and knowledge base of our people at ground. End of the day, that plumber is very important, that electrician is very important, that mason for building water tank or ESR or sump, very, very important. Kindly focus on skilling. Last not but the least, water quality testing by village community. School teacher, Anganwadi worker, Asha worker, BWSC member, kindly focus on that. I think you are basically in the cusp of, great, something terribly great you are doing. And I think we can do it. So friends, I'll take, I'll close this session here. And if you have any other announcement to make this thing, thank you very much. Keep up your good work. Keep up your passion. You are doing great work. Be very proud of. And don't forget that this work must be put on database, IMIS, and B, the write-up should be shared. You must get recognition for work you are doing. And that is my job. I am here just only to help you basically, that whatever good work you are doing, that should be amplified, people should know, and that can be shared. So once again, wishing you all very best in a very challenging time. Wish you very best to your colleagues and your family. Stay safe. Take care of everybody. Thank you very much. We will be announcing the next episode of, I think on next is 26th. I think we will skip this 26th because we propose to have a program, a nationwide program on good governance on 25th. We will very shortly, within a couple of days, we will be announcing and will coming to you. Last, I am requesting my colleague, Mr. Pradeep Singh. There will be online directory, online public health engineers directory. As we are building the directory for NGOs, directory for Gram Panchayat or Water Sanitation Committee, similarly Director of Public Health Engineer. Your department you are having. My request is at the state level that this data should be populated in that directory so that from top to bottom, all public health engineer, chemists, hydrologists, all those team, public health department, their name, designation, address, phone number, email ID, everything is available. We will keep email and phone number hidden. We will keep email and phone number hidden. Okay? Unless you want that, it should be made for. And this database should be available so that in next 1 month, 2 months, we should be able to create a very excellent group so that data, information, this gap is filled. Whosoever needs information, they are on same page. Kindly, next 3-4 days, I think that will be made operational and upload the details. We don't need too much detail, just like your civil list, that data should be available, except one thing, we would like that whenever we want a district wise, that in this district, these are the 2, 3, 4, 5, 10 officers, starting from JE to executive engineer, whosoever are that. So district wise, we should be able to call out. Okay? So kindly finalize your civil list and that should be updated here. Okay? Thank you all very much. Thank you. Have a nice weekend. Thank you so much. Take care.